Good day once again. We are down on the second log for the differential calculus. Now our topic is on maxima and minima. So we are going to solve another problem, but this time we're talking about maxima and minima. So we are going to solve one problem here, and you've got four choices. So we're going to determine the diameter of a cylindrical boiler if it has a volume of 1,340 cubic meter, and we have to make sure that the cost of the metal sheets to make the boiler should be minimum. So the question is, what should be the base diameter of the cylindrical boiler in meters? So we have four choices here. A is 7.08, B is 11.95, C is 8.08, and D is 10.95. So again, the question is, what should be the base of the cylindrical boiler in meters? So we are given here a cylindrical boiler. So that means we are going to make use of the volume of the cylindrical section. So if this is the cylindrical boiler, we've got the height of the boiler here, which is denoted by letter H. And of course, the variable that we have to determine, which is the diameter of the boiler. So since we have a cylindrical section, then we are going to make use of the formula for cylindrical section. So that means your knowledge in solid mensuration is very much applicable here. For the volume of cylindrical section, all we have to do is to multiply the area of the base of the cylindrical section by the height of the section. So we have pi d squared over 4, which is the area of the base. You multiply it by the height of the section. So we are going to make use of this formula for the volume in order to make the cost minimum, and that the area should also be minimum. Remember that according to the problem, the cost of the metal sheets should be minimum. And for us to make use of a minimal cost, the area should be at the minimum. So using the formula for the volume, which is given here, we can have minimum area of the section. So from the equation of this volume, because we are given 1,340 cubic meter as the volume, we can equate this with pi d squared over 4 multiplied by the height of the cylindrical section. And again, to make the cost minimum, the area should be minimum also. So the minimum area should be the area of this cylindrical section. So the area will be the lateral area and the area of the bases. So remember that this is a rectangular cylindrical boiler. So the section is cylindrical also. So that means you have to determine the area of the bases first, plus you add the lateral area. So the area of the base, if we are going to use the formula for the area, the formula for the area is equals to pi d squared over 4. That was the formula for the area of a circle. Since we have two bases here, we are going to multiply it by 2. And because we are looking for the total area of the section, we have to add the lateral surface area. The lateral surface area is simply equals to the perimeter, or I mean the circumference of the base of the circle, and you multiply it by the height. Remember that the formula for the circumference of a circle is pi times diameter, and you multiply it by the height. So again, take note that since we are looking for minimum cost, the area should also be at minimum value. So that means we have to minimize the value for the area. So using this formula for the area, to make cost minimum, the area should also be minimum. So that means you have A, or area, is simply equals to pi d squared over 4, because we have not yet determined the value of the diameter. That is the one in question. Let me just erase this one. It could be rewritten as pi d squared over 2. So that was from 2 divided by 4. So pi d squared over 2 plus, of course, you have pi d, and you have pi d. And take note that if we are going to express h in terms of d using the formula for the volume, because we would want to have a consistent variable, a known variable, so we might as well express area in terms of d by expressing h in terms of d also. So if we are going to express h in terms of the diameter, we will have 1,340 times 4 is equals to pi d squared times h. And that would give us 1,340 times 4 all over pi d squared. So that is how we express the value of h in terms of d. So you have 1,340 times 4 divided by pi d squared is equals to the value for h. So then we can now simplify this equation for the area. So you have the area is equals to pi d squared over 2 plus, of course, you can cancel pi, and you can also cancel one of the d's. So that would give us 1,340. You multiply it by 4 all over the remaining variable d. So this will be our equation for the area, and this equation will be the one that should be minimized. So we are going to determine the derivative of A with respect to D, or the derivative of the area with respect to the diameter. So Now, we are going to determine the derivative of pi d squared. So, the derivative of pi d squared is equals to pi over 2. Take note that if we are going to determine the derivative, the exponent shall become numerical coefficient, and then we will have d with the exponent of n minus 1. And then you are going to add. Now we are going to add the derivative of this portion, 1340 times 4 all over d. And so we have here the answer, 11.95 meters. So for this particular problem of a cylindrical boiler having a volume of 1,340 cubic meter, the cost of the metal sheets should be minimum, and we have to determine the base diameter in meters. And that's it for the first problem that we have for Maxima Minima. Thank you very much for watching and listening. Hope you learned something from it. See you on my next vlog.